Alright, the recording is rolling. Hi everyone, thanks for jumping on the meet. For our IoT group assignment, we need to present a comprehensive use case analysis based on chapter 6 of our syllabus regarding IPv6 technologies. To keep our report highly focused, I'm proposing we analyze just the very first scenario from the IoT6 European Research Project, the smart office and the legacy device integration. We need to explain how IPv6 bridge the gap between old hardware and the modern internet. Return. To set the stage, what is the exact problem with building automation today that this use case is trying to solve?
Right, let's look at the baseline problem. The building automation right now suffers from a massive heterogeneous landscape. We have a huge variety of legacy devices and isolated networks. For example, the heating system might run on the BACnet protocol, while the motorized sunblind runs on a completely different KNX protocol. This legacy network cannot talk to each other, and more importantly, they cannot natively connect to the internet. Integrating them through a single, unified interface is a massive challenge. Right now, facility managers have to use completely separate software platforms just to control one single room.
So it's basically a language barrier blocking them from the Internet of Things?
Exactly. They are trapped in their own local networks. The primary use case here is using IPv6 to finally break down those walls.
And that is exactly where the core hardware solution comes in, the IoT6 gateway. To fix this fragmentation, the architecture places this gateway right between the legacy networks and the internet. The gateway's main job is translation. It takes those proprietary KNX and BACnet message and wraps them into standard IPv6 package. By doing this, the IoT6 gateway provides a completely homogeneous view of all the underlying heterogeneous networks. To the outside world, these old devices just look like standard IPv6 nodes.
Taking over from Weifeng, let's look at how a user actually triggers this system. The scenario starts when an employee arrives at the building. Instead of a traditional closed-loop key card system, the employee presents their RFID badge through an IPv6-enabled RFID reader. Because the reader is natively IPv6-enabled, it bypasses local controllers entirely and communicates directly over the internet to the CMS, the control and monitoring system. This proves the power of IPv6. The edge device talks directly to the cloud without needing middleware.
And that CMS in the cloud is where the actual intelligence lies with. When the control monitoring system receives that RFID logins, it identifies a specific employee and automatically selects their pre-configured comfort profiles for their specific office. The CMS does not care if the office is used KNX or BACnet hardware. It just sends the standard IPv6 commands back down to the IoT6 gateways, instructing it to prepare the room for this specific person.
Once the gateway receives the IPv6 command from the CMS, the execution phase begins. The gateway translates the command back into the legends language. Let's look at the BACnet side of the office first. The gateway sends commands across the BACnet networks to adjust the heading auto actor, adjusting the set points to the employee preferred temperature. Simultaneously, it sends command to the brightness auto actor, turning on the lights to the access level specifics in the conform profile.
At the exact same millisecond, the gateway is also executing commands on the KNX network. It sends a command to adjust the position of the motorized sunlight, perhaps lowering it to block morning glare based on the user preference. So for the CMS in the cloud, the idiosyncrasies of KNX and BACnet make absolutely no difference. So the gateway transparently integrates everything, allowing the system to adjust heterogeneous device in a totally uniform way.
The architecture is brilliant, but the real energy saving happened during the exit scenario. A similar workflow triggered when the employee leaves the office building at the end of the day. As soon as they present their base to the RFID reader to take out the CMS, is instantly informed that employee is leaving. The CMS then execute an automated energy saving loop. It sends a command back to the gateway to actively turn off the heating light and reset the sun bright in that specific office.
I want to add an alternative trigger to Jinglang exit scenario because relying purely on an RFID checkout isn't foolproof. What if the employee just walk out behind someone else without tapping their badge? The architecture accounts for this. The alternatively, a physical presence sensor installed inside the office can be used. This sensor monitors the room and if it detects no movement combined with a specific timeout duration, it assumes absence and initiates the exact same energy saving scenario automatically.
Our analysis, we have to highlight the business value of this using case to our lecturer. Why do this instead of just buying new smart equipment? It's about avoiding the rip and replace nightmare. Ripping out thousands of meters of BAC net and KNX wiring in a high-rise building would cost millions. This IPv6 architecture allows building owners to keep their expensive legacy infrastructure while instantly upgrading it to a modern, cloud-connected Internet of Things ecosystem. It saves a massive amount of money while delivering state-of-the-art energy management.
This is the fantastic breakdown, guys. By focusing purely on use case 1, we managed to cover the hardware, the networking, and the cloud logic, and the business value in the great detail. Since we're using this recording to draft our final chapter report, let's do a quick recap. I want everyone to explicitly state the specific technical arguments they are going to write about in their section. Yichen, your opinion.
Galit, I'm handling the baseline problem and legacy fragmentations. I will write about the isolation of traditional BAC net and KNS networks and explain why the lack of single interface prevent the true building automations.
I'm taking the IoT6 gateway and translation layer. I will detail how the gateway masks the heterogeneity of the network to explain the mechanism of wrapping legacy protocol in IPv6 package.
I'm covering the IPv6 and direct cloud communication. I will document the workflow of the IPv6 enable RFID reader and explain why bypassing local legacy controllers is a massive advantage for IoT speed and scalability.
I will write the control monitoring system CNS logics. I'm going to focus on how the cloud database maps to RFID logins to the specific employee comfort profiles, generating the downstream IPv6 commands.
In my opinions, I will document the PACnet SQL phase. I will provide specific example of how the translate command alter the heater, auto actor set points and brightness level on the BACnet sides of the gateway.
Then I will document the KNS execution phase. I will write about the actuation of the physical sublines. I will conclude both my and Peggy session by emphasizing the homogeneous view achieved by the gateway.
I will handle the exit workflow and energy saving loop. I will detail the exact sequence of events when the CMS receives the RFID logout signal and trigger the shutdown of office device.
Okay, then I will take the alternative logic, presents and times out. I will write about edge case handling, detailing how local presence sensor provide a fallback mechanism to trigger the energy saving scenario if an RFID stripe is missed.
And I will write the conclusion, financial impact and business strategy. I'll summarize how this IPv6 architecture modernize legacy buildings cost effectively, acting as the ultimate bridge to the Internet of Things without requiring total hardware replacement.
Perfect. That is a rock solid outline. Every single person has a distance element of the smart office use case to write about, completely grounded in the chapter 6 materials. We show exactly how IPv6 solves legacy fragmentation. I will set up the shared Google Doc tonight with this exact heading so everyone can start drafting. Does anyone have anything else to add? I think no. All right, great session, everyone. I'm stopping the Meet recording now.